Good day, I am Jamal Baluma and reporting the Chapter 8 Organization for Production Manufacturing. Objectives: to understand the importance of manufacturing in the organization for production, to explain briefly the factors in involving manufacturing, to give the different classification of production control. Production or manufacturing, as it is more commonly called, is concerned with making of things, the creation of form utility. Etymologically, the word manufacturing means making by hands. However, very few articles are now made solely by hands. Even the simplest type of manufacturing necessitates some tools. There are hand tools and machine tools. In addition to tools, various types of equipment are often necessary, depending on the nature of the manufacturing process. The basic function of manufacturing is to change raw materials or secondary materials into a more useful form or state. It may be involve a changing of the nature of the material or a changing or its form or both. Together with selling, manufacturing constitutes one of the two basic functions in the business. Finance is of course essential to both manufacturing and selling. The factory office group may include, in addition to the actual manufacturing unit, a factory office, a small personal staff, production control, the plant engineer, the chief inspector, the product engineer, purchasing, receiving, shipping, material stores, traffic, and cost. The organizational structure of manufacturing company would depend a great deal on its size, diverse company objectives, and the philosophy of staff management. Types of production processes. The methods by which the materials of industry are produced or manufactured in the things that industry or consumers want are known as production processes. According to one classification, production processes are first extractive, second analytic, third synthetic, and lastly fabricating. First, extractive processes. In some industries, the basic production process is one of the extracting substances from the earth or the sea, known as the extractive process. Example of this process are the mining of coal, iron, ore, lead, gold, and silver, drilling for petroleum, and the extraction of magnesium and other chemicals from the ocean. Second, analytic process. The analytic process is one in which a basic substance is broken down into a number of other materials, which may or may not bear any resemblance to the parent substance. Third, synthetic process. Synthetic process refer to those industries in which a number of different materials are combined to form a single product. In the manufacture of steel, glass, rayon, and dinnerware, the final products are quite different from the original ingredients because of physical or chemical changes. In other industry, such as in the production of automobiles, electrical appliances, fridges, and television sets, where the materials are merely assembled without undergoing physical or chemical change. This process is sometimes called the assembly process. Much of so-called manufacturing in the Philippines is still of the assembly type. Instead of manufacturing or fabricating parts in the Philippine plant units, the knockdown parts are usually imported from abroad and to put together in the local assembly plants. Many assembly industries are now experimenting with locally produced parts that would do away with imported ones. Eventually, produce parts that would do away with imported. Fourth, fabricating process. The term fabricating process, although used principally in the structural style, business refers to the process that is rather widespread in the industry, wherein a material has its form changed to some extent by being machined, woven, cut up, pressed, finished, or treated in some other manner. It is sometimes called the converting process, particularly in textile field. Example of the fabricating process are found in the manufacture of clothing, shoes, certain types of furniture, nuts, and bolts. Continuous and intermittent processes. A second classification of production processes include: first, continuous process. Unfortunately, the term continuous process has a dual meaning that is frequently confusing. It is sometimes used to describe a manufacturing situation in which the productive facilities must be kept continuously in operation relatively long periods of time, necessitating the day and night shifts and Sunday work. In the steel industry, for example, the furnaces must be kept hot once they have been let until a shutdown is caused by a mechanical failure or a lack of orders. If the furnaces are allowed to cool, they must usually be rebuilt before they can be used again. This situation is also true in much of the chemical industry, where once the production processes have been started, they must be carried through the completion without interruption. Second, intermediate process. Here again, as with its quarter part, there is double meaning to intermediate process. In its first sense, the term refers to any manufacturing process that can be stopped at will, for example, at the end of each day, and that can be started up again the next morning with no difficulty. Under this concept of term, almost any industry that operates a purely one ship a day basis would qualify. Increasing production. First process in production have been used to good advantage in marketing, transportation, office management, and other business functions. It is in manufacturing, however, where we find greatest application are mainly responsible for the progress of industrialization in advanced countries. These processes are specialization, standardization, simplification, and mechanization. Specialization refers to the narrowing of the field of activity. A company may specialize in products. Instead of putting out a variety of radio-electronic products, a company may specialize in only a few kinds of transistor radios, which it would then develop to a high degree of quality and perfection. Specialization may be applied to processes, to equipment, or level skills. Simplification refers to the reduction in the number of types, sizes, forms, designs, colors, and other characteristics of a product. When a manufacturer of clothing reduces his products to three basic sizes of small, medium, and large, he engages in simplification. If instead of putting out shirts of numerous designs and interlocking colors, he puts out only a few basic and plain colors of shirts, he uses simplification to reduce his inventories of raw materials, to affect economics and lower costs of manufacturing, and to increase efficiency of the manufacturing process. Standardization refers to the setting up of standards or norms as the size, quality, form, measure, weight, or other similar feature. For instance, electric light bulbs are generally standardized such that a bulb purchased anywhere can fit a socket in any home. Automobile or Jeep parts are standardized by manufacturers to enable mass production and easier repairs. Standardization enables interchange of parts. Mechanization refers to the development of machines to perform as much of the manufacturing process as possible. Manual skills of workers are supplemented by machine skills. A mechanist printing establishment may use a folding and binding machine to take over the work of 20 laborers in the end processes of preparing books. Further to mechanization is the process of automation, where given effort is further reduced to a bare minimum and where servo mechanisms even take over supervision and adjustments of operating machinery. The organizational structure which industry has traditionally used may be further shaken up. Automation comes into fuller application. A new method of scheduling is called PERT. PERT, which means Program Evaluation Required Technique, is a project management planning tool used to calculate the amount of time it will take to realistically finish a project. PERT, introduced in 1968, is like some other managerial techniques, a planning controlling technique. The basic analytical device of PERT is a network consisting of a pictorial description of the necessary work. This network is made up of activities and events that comprise a project. An activity is shown by an arrow of an event by a circle. The former represents work required to accomplish an event. Estimates of time to complete each activity are indicated on the network. There are different formats for calculating pertinent data of the network. Commonly, an average value is determined for the estimated time. Subsequently, the earliest expected time to achieve the activity from the entire network viewpoint is calculated. This value is the sum of the expected times along the longest path from the start of the network to the event in question. Finally, the latest allowable time is determined. This is the time by which an event must be accomplished to meet the scheduled completion date of the entire project. It is the value found by the subtracting from the scheduled length of the project the length of the longest path backwards from the finish of the product to the event in question. PERT is advantageous for non-repetitive, non-routine projects. It is being used in the research and development projects, the conducting of new products, developments and preparation of building bids and proposals, periodic maintenance shutdowns, pilot plant runs, and the construction of buildings, bridges, and power stations. It helps, first, focus attention on potential problems in a project. Second, reasonably predict the attainment of project objectives. Third, evaluate progress toward this attainment. And lastly, indicate feasible adjustments and related activities to improve overall project accomplishments. Factors involved in manufacturing. The manufacturing of any article involves the following factors. First, design. Second, materials. And lastly, processing. Design. The design will be standard, state, and unchanging, as in some articles of staple merchandise. It will be variable and subject to change overnight, as in the case of some lines of style merchandise, where the change may be imperceptible, affected over a fairly longer period of time. Requirement of design. The design of an article must meet four requirements, namely, first, consumer acceptance, second, utility, third, economic processing, and lastly, proper kind of material to be used. Consumer Consumer acceptance. The design of the article must have what is called consumer acceptance. The article must appeal to the customer's taste or desires. A shoe manufacturer, for instance, who manufactured an in-out style of shoes for men would find very little sales for his business. Few men today wear such styles except for occasional needs. If he ships to boys and teenagers shoes for the same style, he may find a bigger marks. One of the problems in consumer acceptance is the changing of styles so rapidly that the production for stock may be a questionable practice. Again, trying to find out consumer wants is not as simple a process as it sounds. Second, utility. The second requirement of design is that the product shall adequately serve the purpose for which it is intended. The product must be useful. A beautifully designed and attractive chair may not be strong enough to serve as a chair for day-to-day use. Not too many families can afford purely decorative furniture, especially if there are many children. Utility in an article is indeed an imperative consideration in design. Consumer desire for beauty should be harmonized with utility. The third one is economic processing. As a third requirement, the design of an article should not be a cost for the use of uneconomical manufacturing processes. If the design slows down the process of manufacturing, high cost of production will result. This will make it difficult for the products to be sold at a profit. In other words, product design must be carried to a stage where it can be labeled production design. A design that can be manufactured in the quantity desired and at cost in line with the price obtainable for the product. The fourth one is kind of material to be used. The fourth requirement of design is that it must suit the material of which the article is to be worked to produce the design wanted. Some materials are more workable than others. Some processes can be used with some materials and not with others. As an example, we have the case of copper, which is more ductile than any other common metal. Thus, it commands universal use in electrical wiring. Some aluminum wiring, on the other hand, has been developed. Copper is impervious to explosion, except under the long exposure to certain acid fumes, and is an easily workable metal. The plastics, which have developed amazingly in the last decade, have introduced new possibilities into manufacturing of articles. Some of the plastics have inviolable strength, being practically unbreakable. Impervious to acid, weather corrosion, and so on. Combination of plastic materials may result in beautiful finishes. There is even a plastic house paint claimed to be impervious to sun and rain. Choice of materials. As a second factor in manufacturing, the choice of material, among other things, depends on utility or purpose, durability, and cost of development of manufacturing of the product. Utility articles may have either a utility purpose or decorative one, sometimes both. An ornament has little utility if it is used merely for decorating something like a house. Such decorative articles carry temporary consideration. The main considerations in which cases are cheapness of material and expensive methods of manufacturing. Durability. Articles with utility purpose are made with some consideration for durability. The choice of durability material is desirable. At the same time, economically manufacturing is also desirable in order to keep costs down. Until consumers can learn how to distinguish between good quality and poor quality goods, there will continue to be produced substantially durable items which not last and are not made to last, despite their appearance and possessing that quality. For example, bolts, nails, and other items of hardware are available in durable and non-durable materials, since the super financial appearance of both is much the same. The ordinary consumer does not know the difference in value. As long as this market exists for non-durable products, there will be those who will supply that kind of product. On the other hand, there are consumers who believe that anything worth doing is worth doing well. They want and demand durable goods. When such a buyer purchases nails, for example, he buys a house paint, he wants paint that sticks and does not easily fade. Cost of development and manufacturing. Before undertaking to develop a particular product, the management must be able to envisage a return on the product that is commensurate with the cost of development. It goes without saying that this requires not only forecast of the market for the product, but also the knowledge of time, effort, and equipment required in its development. Also important is estimated cost of manufacturing the product, which must be done economically, otherwise the product will be of little use. Processing and manufacturing, the third and last factor involved is processing, which require machine and labor. The proportion, however, of each is seldom the same in the manufacturing of different products. For example, the manufacture of safety razor blades uses highly automatic machines, several of which may be tended by one person. Other processes, however, may require two or three or more attendants to a machine. Trend to automaticity. The tendency in a machine design is to make machines more automatic in their operation so that less labor is required. The early printing machine was operated by hand, while the modern printing press is run by an electric motor and fed automatically. The trend is generally toward more and more automatically. Advantages of automaticity. It is obvious that the more automaticality in an operation, the less labor is required and consequently the less costly they will be. Inasmuch as the cost of manufacturing affects the selling price of the product, it is therefore responsible for one manufacturing concern of similar products to outcompete with competitors in the same field. If he can cut costs and charge a lower price for the same quality, a lower price brings the articles within the reach of more purchasers and thus opens up a wider market. Layout influences production. Another determining factor in production is layout. This refers to the arrangement of machines and equipment in any kind of work according to the sequence of operation. There are other factors influencing an ideal arrangement. Some of these factors are the size and the shape of the space available, accessibility, convenience, transportation facilities for moving materials, light and power facilities, and others. Sometimes these influences can be wholly or partly satisfied or overcome. Sometimes they are insurmountable, especially if to correct them requirements the outlay of money that is not available. Efficiency of labor. The efficiency of labor likewise has a marked effect on the price and market. When Mr. Henry Ford in 1914 set a $5 a day minimum wage for all workers, he took a step that assured him the peak of the mechanical skill in the country. When in 1940 Mr. James F. Nelcon paid each of his employees a minimum of $5,000 a year, he was able to cut his manufacturing cost to one-fifth of his nearest competitors. The same is true in the Philippines. The bigger, reputable, and more progressive companies, the less they manage not only to survive but even outsell their competitors. Control of production. In the Buddhist sense, control of production signifies the management of manufacturing. Primarily, it is concerned with the aspect of time, place, and quantity. Control of production uses all the information indicating what is to be made, from what is to be made, where it is to be made, and how it is to be made. It also furnishes the specifications, instructional details, and proper work necessary to carry out those plans. It gives data to the manufacturing unit and collects reports on performance as a guide for future operations and to check on current performance. Production control facilitates the flow of work, sees to it that the parts are needed when they are needed, and enables the company to meet time schedules. Production control is used as a wedge in tracing waste, loss, and many business failures. It serves as a powerful and profitable mechanism when properly applied. The manufacturing process, made up of various sequentially production operations, is determined in production planning. But when choices are available, the selection is made based on only a machine or space availability, operators, skill, and cost, but also on the time allotted to the work. In addition, the time when each operation should commence and when it should be finished are also calculated. For this purpose, time standards are used, otherwise scheduling would be meaningless. Possible alternative to the selected manner of production must also be made of the time calculated for work completion by the alternative routes. Those alternative arrangements are necessary, and the effective handling of the contingencies that must be provided for in a production control work. For clarify of discussion, the essential production data utilized in production and control consist of routing, scheduling, and dispatching. Routing concerns the establishment of the path which the production will take in its travel through the plant. The route sets for the fourth operation to the perform are the sequence to be followed. The machine's attachments and work areas to be utilized at each production steps are indicated. In some cases, the specific machine to be used is designated, while in the other cases, only the machine division is named, in which the foreman determines which particular machine will be used. Routing also provides data on the time allowed to complete each respective operation. In addition, the exact quantity of each required material with adequate allowance for spoilage and loss is calculated, and the arrangement are complicated to have all materials at their respective specific shop locations when loaded. Scheduling is the assigning of clock or calendar times for carrying out the various operations. It can be thought of as the time use coordination which seeks to have many operations properly synchronized. Work should not be completed too far in advance of the time we needed because to do so might necessitate extra handling, additional space for storage, and the possibility of product deterioration and loss during the waiting period. On the other hand, work shouldn't be completed after the time needed because of costly details and possible disruption of the smooth flow of subsequent operation. Dispatching. The last part of production control emphasizes correcting the deviation, if any. It includes giving work authorization to proceed with specific batches of work at specific times, securing reports on work progresses, and the granting of authority to move materials from one area of the factory to the other. Furthermore, information of progress at each key production step, quality of work achieved, revised arrangements when original plan is not executed, and the handling of emergency situations such as machine breakdown, shortage of help, and excess waste and material are among the additional responsibility included under dispatching. Inventory control, closely allied to the production control, are often part of it is control of inventories. Inventories are not directly under production control. Their control may be coordinated with the warehousing department. Control of inventories avoids unnecessary waste. A failure to have adequate control may result in the scrapping or throwing to salvage of useful items. Inventory control covers raw materials inventories, goods in process inventories, and finished stock inventories and supplies inventories. A close check of issuance is made. Accurate records that give a true picture of the status of items are established. Quality control. The manufacturing end of business is not only responsible for production, for producing quickly at a reasonable low cost, but it is likewise responsible for the quality of the product. Quality is controlled by having precise specifications and necessary inspection of the product to see that the specifications are adhered to. Usually, however, certain tolerances are allowed, limits within which the product may be vary one way or the other way. Maintenance. Practically every enterprise of any size, hotels, store, school, factory, or utility has its maintenance department. The smooth functioning of the entire operation department is virtually dependent upon the effective operation of the man behind the scenes, the maintenance workers. Breakdown of an elevator, lighting system, etc. usually causes cessation of operation or at least a great inconvenience. Preventive maintenance is more effective than remedial maintenance. And I will end my report by saying if everybody else seems to be doing it one way, there might be more opportunity the other way. Andrew Skerman. That's all. Thank you and God bless you.